Hello, this is simply about networking protocols, and today I'll tell you about ARP, GARP, provenance use case, and ARP proxy. Standards that describe GARP and ARP proxy are RFC 1027 and RFC 5227. They contain more use cases, and also you can search in the network for more use cases that using GARP and ARP proxy. I'll tell you the basics about them. So, in today's video, I'll present you regular ARP use case, GARP, what it is, and its use case of provenance, and ARP proxy, what it is, and its use case of subnet segmentation. As you remember from routing videos, from ARP routing, and so on and so forth videos, standard ARP usage use case is the following. First, it is tightly connected to the routing process, and when our device needs to send some IP packet, it look up for RP table for the MAC address of the next hop. Finding this MAC address, our device adds additional Ethernet header to the IP packet and successfully sends this packet to the next hop for the further processing. Okay, but what happens if during RP lookup table is empty, there is no entry for the specific IP? Then ARP, standard ARP process began. It sends RP packets to the next hop, asking for the MAC address for this specific IP. Next hop device, neighbor device, replies with its MAC address in the RP reply. This information is added into RP table, and then routing process can successfully happen. This is on the single device. Schematically in the network, it can be displayed like that. So we have our device that trying to send IP packet to the next hop. This is the next hop. For some reason, our device doesn't have RP entry for this next hop, so it sends RP request asking for IP address of the next hop. Usually this RP is broadcast, can be unicast. It always read the documentation from your vendors. When RP entry gets to the device, our device takes this for processing, adds entry information about originator of the RP process into RP table, generates RP reply, its RP reply goes to the originator, and information is added into RP table. And then routing process can proceed without problems. Now talking about GARP. GARP is a process of generating RP packets with specific structure. So fields, how fields in GARP packet differs from standard RP packet is described in the specification. The overall structure is the same, the difference only in the values that different fields contain during this procedure. So usually GARP process is generation of the RP packet not in response of RP request and not due to failure of RP table lookup. For any other reason, then it is called GARP. The most standard GARP use case is provenance. So imagine that our device or its interface appears ready for the participation in the network and applies IP address. This could be manually configured or received by DHCP or by any other procedure. Previously configured, freshly configured, device gets up, interface gets up, root became active for any particular reason, device and its interface is ready to participate in network as L3 interface with some specific IP. In order to verify that this IP is legal for the network and not is used by any other device in this network, probe procedure starts. Probe procedure generates specific probe ARP packet that contains IP address that interface or device will use, and send this RP packet to all devices in the network asking, as anyone has it. When we have device with this IP already in the network, device replies that yes, I contain or I'm using this IP, and then our new or fresh or starting device or interface notifies system that this particular IP address cannot be used. So please, let's think about how we can change it. Administrator will be notified, DHCP server will be notified, whatever, depending on the procedure how IP address was applied to this device and when and how it can be changed. In case RP probe was sent and during specific timeout was not received anything, was not received RP reply claiming this IP address is used with different MAC, this IP is applied and our device now ready to operate with it. Please notify that unlikely from the standard RP procedure. In this case, when we're sending, proceeding, receiving RP packets of probe, this information is not added to the RP table on any device. But once we agreed or didn't rejected this IP address, it is good to notify everybody that this particular device will use this IP address. And then second stage starts, announce. RP packet with announce structure is generated by our device, sent to the network, broadcast, and every receiving device that operates with IP and RP receiving this will add our IP in MAC into RP table on the receiving device. This is how most standard and known GARP procedure works. And now to RP proxy. I will display RP proxy on subnet segmentation use case because it's the simplest for visualization and understanding. RP proxy, this is procedure when device that is aware about this functionality being RP, the device that can be RP proxy, replies to RP request instead of other devices. How it works? For example, we have multiple devices in same subnet, but for some reason they are segmented due to physical specific of the network, too many devices, whatever. For any reason, they are segmented. They do not have direct access to each other. Then, device with IP3 MAC3 and IP4 MAC4 could be announced as RP proxy if those devices can operate as RP proxy. What happens then? For example, our device with IP1 MAC1 wants to send traffic to device with IP2. Then they are on the same subnet, so they could communicate directly, if not this specific of the segmentation. Our device send RP request saying, device with IP2, what is your MAC? Our device that is RP proxy aware replies instead with its own MAC that it has IP2. And then our device will send all traffic with destination MAC of our RP proxy device. This information will be stored in RP table, actually. And how it works then, those devices that are ARP proxy aware and can operate as ARP proxy are routes. So they have routing functionality configured in the way that they routing traffic from one subnet segment to another subnet segment. For example, like here, they have fully operational fib table. Then device receives IP packet that destined to another device. This device knows exactly route to this device, so standard routing procedure happens similar to what was described in the routing video. And this works in both ways. When device in other segment tries to find out device in first segment, ARP proxy device replies instead saying, give everything to me. This information added into a ARP table on the original device, and all traffic will be routed. That simple about ARP, GARP, and ARP proxy. Have a great day.